Hello, everyone, and welcome to DevOps Thursdays, or the Champion Azure Collection series. Good evening, good morning, and good day, wherever you are in the world. Welcome. My name is Erika, and I am the program manager at MicrosoftReactors.com. Today, we are going to start with the Championing Azure's DevOps focus. Oh, sorry, I totally lost my words there. So today we are kicking off with the Championing Azure series that is aimed to provide the necessary skills in Azure and is perfect for you that is early in your developing career. This series focuses on three Azure functions: AI and machine learning, cloud native, and DevOps. Throughout our hands-on workshops, we are going to introduce the basics of Azure and demonstrate what the platform is capable of. For the next 6 weeks, on Thursdays, we have beginner content in Azure DevOps, or DevOps Thursdays, as I call it. Before I begin, I would just like to say a very quick word about Microsoft's Code of Conduct. We all come from different backgrounds, but we are all here to learn. So just please be aware of each other and be welcoming and respectful. Thank you. And now let's move on to the real reason we are all here today, and that is Magnus Timner, our speaker today. Magnus is the VP and a partner at Solidify AB, Sweden, Stockholm. He is a cloud and DevOps consultant, as well as a Microsoft Developer Technologies MVP. And today, I am very, very happy to welcome him to the series' first event, an introduction to DevOps. In this session, he will introduce the basics of Azure DevOps, and we will go through the main pillars of Azure DevOps: repos, boards, pipelines, test plans, and artifacts. This session is going to run for about 45 minutes with some questions at the end, but I encourage you to ask your questions throughout the session. Now I think I've spoken enough, so I will hand over the word to Magnus, whom I will welcome here on the stream. Hi, Magnus. Hello and welcome.
Thanks,
Thank
Erika.
you so much for joining
Thank you,
today.
and thank you for this nice introduction, and thank you for being here.
Yeah, I got a bit lost there with my words at the first, but
Yeah,
I picked up.
no
Anyhow,
problem.
yes, I am going to, leave the word over to you, and I'm just going to put myself in the background, but I am here if I'm needed. Okay?
Great. So let's kick off this introduction to DevOps. First, me. Erika already gave you a real nice introduction about me, but I'm a principal DevOps consultant at Solidify. I'm also a Microsoft MVP. And I've been working with DevOps for years, and since the project or product actually came in 2005, where it was called TFS in those days. But enough about me. I'll just continue. With me, I have my colleague Matthias. He won't be speaking anything, but he will answer your questions in the chat if you have anything, and help me out if we have any problems. And he's our CTO at Solidify and also a Microsoft Developer Technologies MVP. So let's get started with the actual presentation. So today we're going to speak about two things actually. First, I would like to start with what is DevOps, because DevOps is a way of work. And then I'm going to speak about Azure DevOps, that is a product. And they are very much connected to each other. So before we start talking about the product, we will start talking about what DevOps is. So DevOps is the union of people, processes, and products to enable continuous delivery of value to your end users. And that is something written by Donovan Brown at Microsoft a couple of years ago. And it tells us that DevOps is just not a role for persons. It's not a technology. It's delivering continuous value to your end customers. And on the right side here, we see the continuous delivery flow that we start maybe with planning and tracking. Then we continue with development. We continue with build and test and deploy and operate, monitor and learn, and back to plan and tracking. So this is continuous delivery of end value to your end users. So no delivery without end users. We have something, I like this slide. This shows us something called the DevOps Evolution and what DevOps is. So without DevOps, we're using mostly manual processes. We don't have any source control or anything. So I still from time to time meet teams that don't have any processes at all when they work with the code. They have the code on their C drive or in OneDrive or something, and they deploy from the machines. And that's of course not the way I would like them to work with it. Next part is like when we get started with DevOps, there we start to use source control. That can be in Git or it can be other source control providers. We have some kind of automated build where we don't compile the code on our own machines. We have a build service for that. And we also have some kind of monitoring to see different kinds of errors. Next step is promising. Then we have automated testing and some performance tests. We also have continuous deployment. That means that we deploy all the time to different environments. Next step is expert, where we have integration testing and automated code analysis as well. Last part is the hardest one, of course, specialist, where we have automated rollbacks of what we do. We have A/B testing, and we have also continuous delivery. I'm going to go into all these parts and talk a little bit more in details what they are, or at least most of them. So how do we get started with DevOps? First thing that I would like to introduce you to is continuous integration. And that means that every time we check in something to our code repository, it gets built. And why is that important? That is because if you build something and it fails, then you have written something wrong. And if you check in something that is wrong and some other one in your team takes that latest version of the code, it won't work for him or her. That's why it's important to work with continuous integration to get quick feedback of if your code works or not when you build it. You can also add tests to it to see that your functions work and various code analysis products as well. So that's the first part, continuous integration. Move the white, yes, sorry, white box removed, okay. So next part is continuous delivery, and that means that the code that we have built will be deployed. And it doesn't have to be deployed all the way out to production, but the code we build can be deployed maybe to a test environment, because there we can see that it actually works. We can have testers using it, and this way we can have various stages where we deploy our code and get feedback back to the developers. We can do different kinds of testing in different environments, and we can release all the way out to production, either automatically or with different kinds of manual approvals on the way. Does it look strange on the screen? Well, let's continue. Source control is the next part. Without source control, we don't have DevOps. And why do we need source control? It's because maybe we need, mostly you're not the only one working on your code. We probably have other people or other teams working with our code, and it's important to different people or teams to work with the code at the same time without disturbing each other. So here we have a master branch. That's where our main stuff is done. But we also have feature team 1 and feature team 2 that are doing different stuff that is going to be released in different times. So we can work in parallel. And when feature team 1 is ready, they can deploy their stuff to master and from there deploy it out to production. So source control is important to work together as a team, or if you're just one individual, you can work with different features to be released on different times. Next is Agile Planning. So in some way, we need to know what we're going to do. And for that, we can use, this is a Kanban board. You probably have seen this yellow stickers on a whiteboard, and this is just it's the same thing, but doing it with a tool. So we can work with a Kanban board where we can have lots of stuff in the to-do column, and over time we can move it to in progress when we start working on it and go through the entire flow until everything is done. And we can assign different parts of the different tasks to different people, and we can prioritize and that kind of stuff. We can also work with methods as we can do sprint planning and to work with different features over time as well. I'm going to show you that soon. Monitoring and logging is important as well, because if we run stuff or build stuff, we need to know how well we are doing. If we're not doing good, if we're deploying lots of stuff, but it doesn't work, then we get to know that, because we don't want the customer to call us and say, or mail us, say, Magnus, your product is not working. What's happening? We want to find the problems we have before the customer does. And we also want to monitor what parts of my applications are used, because if I have a big part of my application that is never used, I have to look into why should I even have that part, and doesn't the customer find it, or what? So that's monitoring and logging. Next is public and hybrid clouds. I mean, data centers has been there for ages, but it's kind of hard to scale them sometimes. So public or private clouds or hybrid clouds could be a good solution of getting good scalability of your applications, and also spreading them on various regions also. If there are problems in one region, they can automatically fade over to another one, and so on. So public and hybrid clouds is an important way of work as well. Next is infrastructure as code. I mean, we have our code as code, of course, but we also want our infrastructure as code, because if we sit in Azure and we create a resource group and we add a database and everything, we don't want to do that manually, because if we want to do that the next time, it's easy to forget something. That's why it's important to have your infrastructure as code and store it together with your code, because then you can easily spin up a new environment whenever needed. Next is microservices. I mean, most or many old applications are monolithic, which means that everything is tightly coupled together in layers. The new way of working is, or it's new, it's not new, but it's been there for a couple of years, is microservices. And with microservices, we split up our applications in different services that work together. And it's easier for several people to work with different services, and you can couple them together in different ways. So microservices is a good way to go. Next we have is containers. And containers has been there for a couple of years as well, but that is packaging your application in a container. And with containers, you can work with Azure or any other cloud or on-prem as well. It's easy to move your containers between different platforms. It's easy to scale out when needed. If you have an application under big load, it's easy to scale them out. So it's also a good way of working when you're working with DevOps, to think containers. So DevOps may be a pain in the beginning, but it's worth it in the long run. It's lots of good best practices there that you should take into use. But start easy. Don't do everything at the same time. Next, then, that's the actual product, Azure DevOps. Azure DevOps has been here since 2005, and it was called TFS in the old days, and they changed the name a couple of years ago to Azure DevOps. And Azure DevOps is an integrated and independent tool supporting your DevOps practices with any language, any platform, any cloud. And Azure DevOps is actually we have two different flavors. The one to the left, Azure DevOps Services, is provided as a cloud service by Microsoft and hosted by Microsoft. And they roll out new features and capabilities every 3 weeks. And it's hosted in Azure. The other one is an on-prem version, Azure DevOps Service. There you install it in your data center or your cloud. You manage the patching and control. It's controlled entirely by you. And yeah, you can run it anywhere. So it kind of depends what kind of needs you have. If you are in the cloud and do your work in the cloud, then I would recommend the service. Many of my customers are still in their own data centers for different reasons, could be government stuff that is not allowed to be in the cloud. And then we have Azure DevOps Service as a server as a good alternative. So what is Azure DevOps and what do we have here? I'm going to go through all these different parts and talk about them in detail, but we have Azure Boards for the planning. We have Azure Pipelines to run CI/CD as continuous integration and continuous delivery. We have Azure Repos to store our code. We have Azure Testplans to run manual testing. We have Azure Artifacts to share packages, could be NuGet or npm packages or container registry and that sort of things. And if you want to try Azure DevOps out, you can just go into azure.com/DevOps and spin up an environment for yourself. It's free. And it's free for up to 5 people, I think. And you can do what you want there with your code and your planning and everything. And everything I'm going to show you today, you can try out for yourself afterwards. So the idea with DevOps is, Azure DevOps is, you can actually choose what tools you want. You don't have to stick with all of the tools. I mean, many people I work with stick with all of the tools, but here's an example for that. We use Azure Boards for planning. We use Azure Pipelines for building. We store our code in GitHub and so on. So you can actually, if you have other tools, it's easy to integrate them with Azure DevOps. Here's an example that we have our code in Azure DevOps. We have Jenkins builds and different kind of stuff. And it's also, you can target any cloud, Azure, AWS, Google Cloud. You can, and any platform. You can develop for Mac, Windows, Linux, and you can work with containers, of course. So it's a very flexible platform. So first, drill down to the different parts here. We have Azure Boards, and in Azure Boards, we can track our work with Kanban boards, and we can work with backlogs and team dashboards and custom reporting. So I'm just going to jump into Azure DevOps and give you a brief demo of it. If that was not that one, sorry. Here we have it. So I have created a Azure DevOps project called Reactor Demo. And when we spin up an environment or a new Azure DevOps in the cloud, this one is our own Solidify demo. And under there, we have different projects. And in a project, you can work together with several source control repositories, several builds, and several teams. So it's a scalable way of working. And if we click here, the Reactor demo I created for today's presentation, we can see all the different parts I talked about down here to the left. We have overview, we have boards, repos, pipelines, test plans, and artifacts. And the first part here we see is an overview of what we have. It's a little text that describes the application we have here. In this case, it's a health clinic application. And a little description of what we can do with it and what it does. To the right here, we have some statistics of what's happening in the team for now. How many work items we have, how our builds are doing, the members we have in the team. There are also some dashboards here. And those are totally flexible. It's easy to change them and do other stuff. So here is key information for the team. Like we can see, we have 3 active bugs. We have some unfinished work. And we can see who has assigned the most different tasks here. We can also connect this to Power BI if we want to do cool stuff with our data. So there's a couple of different ways of working here, or different queries that we can work with in Power BI. And we also have a wiki. I haven't created one here, but the wiki is marked down and is stored with your code or separate in their own repository. And I actually created this as a cool Azure DevOps demo generator that I used to create this. And here you can create demo projects and choosing for different kinds of templates. So it's quite cool and easy to get a good demo running because, yeah, it's hard to do everything from scratch otherwise. But what I was going to talk about here was boards. So boards is doing work of different kinds. And here I can just see lots of work items, but I won't drill into that. I'll start with the first thing, a backlog. So a backlog is a list of work that needs to be done in a specific order. So when I work Agile or with Scrum and I have a backlog, I should focus on what's on top. The first one is most important, and then we go down to the end to less important stuff. And there's a role called a product owner that should prioritize the backlog. And if we open a work item here, we have different fields. I can assign it to someone if I want to. I could write descriptions. I can write acceptance criteria, and that is for this product backlog item to be complete. These criteria have to be fulfilled. I can have discussions with people where I can use mentions and other stuff. And if I mention someone, they will get a notification. I won't go into all the other details here, but it's plenty of information, and you can change the fields we have here to add other stuff as well. And if I want to change the priority order, I just drag and drop what I want to do here. So this is the backlog. Another view of taking a look in boards is the board view. And here is a traditional, what we call Kanban board. So instead of having all the work items in a long row, we have them ordered by column instead, state. So here we have some work in the new column. We have a column called develop, one build and test, and one done. So when I'm developing something, in this case, appointment detail info, and I think it's okay, now I'm working with it now, and I drag it to done. And now my team colleagues can say, okay, Magnus has finished this work item. And it's an easy way of getting a good overview of what's happening in the project. I can also add different colors and tags and stuff. So I just added for fun all, was it mobile or was it patent? I don't remember. Tickets or issues was pink. So you can do lots of different stuff here and add different fields and stuff as well. So that's the second way of looking at information. The third one is sprints, and sprint is what we do over time. And if we go back to the backlog column here, we can see that we have sprints, and the sprint we have a period of time from the 17th of January to the 29th of January. We have a sprint as it's going on there, and for that sprint we can drag and drop work items in here to tell the team that this is the work that we should work with under that sprint. So we have dragged 3 work items here. And if we go to the sprints here, we can see the work items, the product backlog items, that is the information we work with here that we were going to do on this sprint. And the sprints or the product backlog items has been broken down into other work items called tasks. And these tasks can be added individually to people. And in this case, we have added cancel appointment to me here, and it's in progress. And when I drag it to done, I just drag it to done here. And I can actually do automation out of here as well. So if I commit code and it's connected to a work item, then it could automatically be closed if I want to. There are other stuff here as well, that some are out of the box and some are added by us, but I won't go into the details here. But there are lots of different planning tools you could use here to get a real nice planning overview and way of work also. So that was the first part of working with boards. Let's go back to the next part here. Next part I'm going to talk about is code. And there we have Azure repos. And there's actually another code possibility here. There was something in the original TFS or Azure DevOps is called Team Foundation Version Control. But when Git came along a couple of years ago, Microsoft decided to start, as everyone else, working with Git instead. So Git is a client that can be used inside Azure DevOps as well. And so I'll just skip into the demo again and go to the next part here, repos. So we have a couple of repositories, or maybe just one. Yeah, but we can add new repositories, new Git repositories here. We can import them, and we can. I won't go into details what Git is, but it's a distributed source control provider. It's kind of world de facto standard, and it's Azure DevOps uses this in one of its implementations, and GitHub is another way of working with Git, and there are Bitbucket and GitLab as well, and a couple of other ones as well. But it's kind of universal standard, and most of you, I guess, work with it already. So here I can see my project, and if I want to, if it's just maybe text files, I can just go in and open them here and edit it here directly from here. So some of the stuff here I might be able to edit, but the stuff down here I wouldn't edit in just a text browser like we have here. And when we check in our code, we do commits, and we can also create, when we check in our code, we can set up different kinds of rule sets. I won't go into that in detail either, but we can create something called a pull request when other people have to look at our code, so we get a kind of four eyes principle view of our code. So before we can commit it to master, some of our colleagues maybe have to taken a look at it, and maybe we set up some kind of build to verify that it's okay to check into master. There's also a couple of other ways of working with our code here. So one quite cool thing is I just click dot, and it actually opens up a Visual Studio Code directly in my browser, where I can work with Git directly with my code. So I think that's really, really cool. So just dot when you are in the repo screen, and then back. Then you can start working here. And it's just like using Visual Studio Code. If you have tried that, we have all the different features here we have in Visual Studio Code. It's quite cool. Another way of working, if we go back to our code here, to repos, we can just click clone up here to the right. And then I have various of options where I can open my code directly in one of these tools. And of course, I have to have it installed on my machine. So in my case, I have Visual Studio Code installed. And when I open it in Visual Studio Code, it looks like this. So I have direct connection. It gets downloaded on my local machine, and I can work with my code here from Visual Studio Code and use all the nice add-ons we have in Visual Studio Code. So that was the repo part. Next is Azure Pipelines. And Azure Pipelines is CI/CD, and that is continuous integration, continuous delivery. And you can run it with any language, any platform, any clouds. It's really flexible. And we have cloud-based. If we want to use, Microsoft have hosted build services we can use if we want to, and they exist both for Linux, Windows, and Mac OS. And if you are a company using it, it costs money, but if you're an open source project, you have unlimited minutes. And I think that is really, really cool. And the importance here that we don't want to build on our own machine, because if it works on my machine, we have no idea if it really will work on the server, will be deployed in the end. So if you're building on your own machine and then deploying directly from your machine, I think that's a bad practice. So you should be using build servers to deploy what you need in a controlled way. So let's just jump back in and take a look at the build servers. Let's close this down. So here we have pipelines. And there are different ways of working with pipelines. And the most, call it the modern way of working, is working with YAML. And let's just create a new pipeline and see how easy it looks. And YAML is like you store your build definition with your code, the same as infrastructure as code. And the first option we have here, where is my code stored? And in my case, it's Azure repos Git. And then I just click on the repo I want to build. And then it analyzes my code, and I can see it says, okay, what kind of code is it? I probably have some different stuff because it selects ASP.NET or Node or, yeah. So I'll just select the ASP.NET starter template here. And here it actually creates a couple of tasks for me. And it creates my YAML pipeline. So it says when I check in something to master, it will trigger the build. That's the trigger. It says that the hosted image I'm going to use is the Windows latest. I can use the Linux latest and Mac latest and so on as well, and older versions. And then it will tell me to some variables we have for the beginning here, and I install NuGet. I run a NuGet command to get the NuGet packages. I use Visual Studio Build to build my code, and I run some testing. And I can add other stuff to here as well to do deployment and stuff as well. So if we just skip this and go back to the pipelines here, and I have created this already. And when I run my code here, I can see that it has been run, and I actually got a couple of errors here. So I can drill down and see when my code was being run on the build server, exactly what is wrong. And here I apparently have a couple of NPM problems that I need to address. There's also another way of working with pipelines. We call it the old way of working. So that is if we open another build I have here. And here we work with tasks instead that you can see directly in the interface. So it's really easy to follow. But I would recommend if you start from scratch now, you should apparently work with the YAML templates, that they are a more modern way of working and it gets stored with your code. And you can also, this is just the build part, and when we're using the YAML pipelines, we can also set up deployment pipelines or do it in the same way. And we can also work with the deploy here from the part called release as well. So we can have a deployment that goes through our dev environment, our QA environment, and to our production environment. And we can set up different approvals doing that as well. So here is a release based on my build, my health clinic build. And here we have different environments going from dev to QA to production. And we have some errors here that just I haven't configured this correctly. So that's why it shows. And if I want to, I can say set up different approvals here. So we can have pre-approvals. And here I can, maybe my colleague Matthias needs to say okay before we go to production, or my product owner or something, or some team. We can also set up different kind of gates. Like we invoke a REST API or an Azure function before we deploy. There's even get Twitter sentiment. So if we have something coming in on Twitter, we can deploy or not. Maybe not really useful, but it's fun. We can connect to ServiceNow and Sonar Cloud and different stuff as well. So the build part is really nice and really flexible. And I've used it a lot during the years. So after Azure Pipelines, we have Azure Artifacts. And as I mentioned before, Azure Artifacts is a way of sharing packages between teams and projects. So if you are working within your company or privately with creating packages, NuGet packages or NPM packages or Maven or anything that can be consumed by others, we can deploy them to Azure Artifacts. And then they can be shared within your company or within your teams to others. It's like similar ways as storing that on NuGet.org or other platforms. So it's easy to add. You can add packages. You can use them in your pipelines, and you can create them with your pipelines as well. And it's an easy way to share your code efficiently. So let's just jump in there and see how it looks. We'll just leave this build here. And here we have a couple of different NuGet packages that has been deployed here. And I can, if I want to, just download them directly from here, or I can connect to the feed if I want to. So let's say I want to do it from .NET, and I get some help how I do that from my CS profile, or if I use NuGet.exe, how do I, yeah, that's also CS profiles or NuGet files or anything. So depending on what kind of platform you use for your packages, you get a lot of help how to connect to it here. And you can do it both upstream and downstream. If I want to connect to a NuGet feed from NuGet.org or somewhere else, I can do that also, and I can get those packages directly in here. So my users can have only one place to get their artifacts, and then they don't have to go both locally and externally. That was artifacts. And the last part we have here is Azure testplans. And Azure testplans is mostly actually for manual testing. And some of you might think that who is doing manual testing nowadays, but we have, I mean, for lots of organizations and companies, it's an important way of working as well. And of course, we should try to have as many automatic tests as we can. But manual testing is, I mean, might not be done in every part of your deployment, but it should be done at least in some parts. And I mean, you have manual testers doing the test, and you want to capture the result in a good way. And if we have a problem in your test, the manual test, then we want to create a bug for it and go back with it to the backlog so we can work with it there. I'm going to give you a brief overview of the test part here. But let's start with going to boards actually, because I like the view here we have. So here for my work items in my Kanban board here, I can actually add stuff here if I want to. So this is a product backlog item. It's a kind of requirement that I'm working with. And someone has actually added tests for this. So I can actually see in this work item here that I have 7 tests here, and I can't see if they've been run or not. So 0 passed, 0 failed, and 7 others. And if I open one of these, I don't know why they are in French, but it's probably something with the template. But just let's click this check appointment notification. We don't have any steps here, so it's just, but we can add a couple of ones. So log in to VVV or something. And then we can have an expected result here. Log in, okay, and then we can continue. Let's pretend we have a kind of bank application. Go to account, balance show. Then we can continue adding steps, and we can actually close this one. And if I want to run the tests, I can, if I want to, run it directly from here. And I get a little window here where I can go through my different steps and I have my bank application or whatever in parallel here. And when I am finished and done the different steps, I can just click OK. And this result will be logged with the test. And if it doesn't work, I can actually, if I want to create a bug as well from it. And so it goes back into the backlog. And for this, I can actually use capture screenshots in different ways. I can use video to record it, everything. So I can get a real rich way of working with the bugs. So it will be easier for the developers to see what's wrong. You don't only get something that the balance is wrong, you get all the steps that they have done with screen dumps and everything on the actual test of what we do. So this is one way of working with tests from the backlog. And if you're a more advanced tester, you can work here from the test plans. So here we have a test plan where I've added one of my requirements, the same one that we saw, and I can get here. I get all the tests I have, and I can add different tests for different purposes. I can add one test for what we are working with now, and I can add other tests for the entire application, and then I can let different people on my team run different tests. And this is just the beginning actually, because if you have the tests automated, you can also, if you have the manual, you can also automate them, and then you can get the automated test results to update here on the work items. So it's really cool. So it's a nice tool. And that was actually what I was going to show you now. So we've gone through the different parts of Azure DevOps. We've also talked about what DevOps is and the key parts of DevOps. So let's continue here. We have a couple of learning modules that I know Erika is going to send out to you afterwards. But I think we can open up to some questions now if we have any ones in the chat. So I will just find the chat. So I see one question there from Ryan.
Yeah, I'm gonna put the questions on the
Yeah,
screen.
and Ryan,
Okay.
that's a real good question. And well, to continue with Azure DevOps for your org or move to GitHub. I mean, Microsoft bought GitHub a couple of years ago, 2 years ago now, I think, and lots of focus is on GitHub. Much of the new stuff is on GitHub as well. So I would say if you were a completely new organization that hasn't worked with Azure DevOps or GitHub before, I would go all in to GitHub from the beginning. If I'm an existing organization, I would probably start looking at moving my code to GitHub because I think the code part of GitHub works a little better than Azure DevOps. I can still do my planning and my builds in Azure DevOps, and it's a really good integration between code in GitHub, builds in Azure DevOps, and also work items in Azure DevOps. Is that an answer to your question? Oh no, we got many windows there. Yeah. Moment. Where can someone as interested in DevOps start as a newbie? Well, those learning labs that Erika will send out to you or post here is a good way of starting because there we have the basics of Azure DevOps and how to get started with in an easy way. And there actually Microsoft Learning has lots of good topics when it comes to working with the different aspects of Azure DevOps and Azure. So I would say the learning labs would be a good way to start.
Yes, the aka.ms DevOps Intro 1 and DevOps Intro 2 links I have just dropped in the chat. These are
Perfect.
the two links that Magnus has just mentioned. Okay, any more questions? Let's see. Magnus says, worth mentioning that you need higher level subscriptions to be able to create the test plans suits.
Correct. Thank you, Magnus, for pointing that out. So if we are in the test plan part of working with creating test plans, then we need Microsoft Test Professional, or sorry, Visual Studio Test Professional or Visual Studio Enterprise. But if we're working with the tests from the boards, as I showed you in the Kanban board, then we don't need that. So that's the light way of working with tests easy. So all the developers that work with the tests can do it directly from the Kanban board. But if you have professional testers working with the test plans, they need a test professional row. Thank you, Magnus. Do you have any suggestions for tutorials, documentation on building pipelines? Actually, we have in, I think, 2 weeks, my colleague Matthias is going to talk about continuous integration, continuous delivery on exactly that topic, and he will provide some links there. So I will suggest you listen in then. Can I benefit from DevOps if I am an infrastructure admin? Absolutely. And first thing I would think of there is storing your scripts in a Git repo. Because when I meet infrastructure people, they might, I mean, they're not developers, or sorry, you are not developers from the beginning. So you might have other places to store your scripts that can be on a network drive or some other place. So the first thing I would do if I were you is to store my scripts in a Git repo. The second thing I would do is to see if I could start working with infrastructure as code and deploy my infrastructure from Git with the build pipeline and deploy it in my target platform. Any Pandabot alternatives in Azure DevOps? So Pandabot is a GitHub product that analyzes my code for third-party dependencies. So like the log4j stuff we had during Christmas and other things, it also checks, if we have any third-party dependencies. So, and that is free in GitHub and it's a really good tool. It's not built into Azure DevOps, but we have tools like White Source and some other tools where we can do the same thing. And I think they have free versions as well. But that's also one good thing with moving to GitHub with your code. You get that for free, the Pandabot. And actually, next time I'm going to speak about GitHub, so join in then and we'll talk a little more about what's good with GitHub. DevOps also removed free build minutes previously offered. Yeah, I think it has something to do with Bitcoin mining, that they were being used extensively for Bitcoin mining. But you should have some free minutes. I don't know how many, but before you had free minutes if you were open source. Yeah, all the minutes were free. Now I think you have a kind of limit for that. I'm not sure exactly. So if most of your work is on premises, do you need the server on your org on-prem, or can cloud builds deploy on your on-premises application service via gateways? So if you have Azure DevOps Service on-prem, it's obviously no problem to deploy on-prem. But if you're up in the cloud, then you shouldn't use Microsoft hosted build agents, because then they need access to your on-prem environment. You don't want that. So in that case, I would install my own build agents on-prem, and they work with a kind of pull mechanism. So they check all the time if there are any new builds on the server, and then they deploy it through their on-prem build servers. So that's a good way to do it as well. The only thing is that we need a connection from the build server out on the internet to connect to Azure DevOps. That's port 443. Do you need coding and programming to be good in DevOps? No, actually, it depends what you do. If you are a programmer, of course, you need to be able to program. But if you use Azure DevOps for planning, you don't need to be a coder. If you use the build and release part, I mean, you don't need to be a coder either. You need to understand the YAML. And I used to program in the old days, but now I mostly do scripting and that kind of stuff. And you can do that in DevOps as well, and it's not that hard. But the base of working with DevOps is coding in some ways. Someone in your team working with DevOps should be a programmer or have programming capabilities. Can you give an example of use cases for Ansible and Jenkins? So, I mean, you can connect your Jenkins build service to Azure DevOps to, instead of using the Azure Pipelines here that I showed you here, you can connect your Jenkins build service and do basically the same stuff you do with the Azure Pipelines with Jenkins. And Ansible, yeah, you could work with Ansible. I'm not totally familiar with it, but you can do deployments with Ansible from Azure DevOps, and yeah, use that as part of the Azure pipeline. And you can probably call it directly from Azure DevOps as well, but I'm not 100% sure. Is there integration with Terraform for infrastructure as code? Yeah, there are build tasks built into Azure DevOps pipelines where you can connect to Terraform. There's actually an entire marketplace with different kinds of products, some created by Microsoft, some created by other companies, and some by private people doing different kind of stuff. So yes, there is integration for infrastructure as code with Terraform. Can we use third-party compilers for building code? Yes. I mean, if you have a third-party compiler and it's on your own build servers, because that will obviously not be on the Microsoft build servers, or some of them can be. But if you just install your third-party compiler on your own build server, and then you can, from Azure DevOps through command line, or so rather Azure Pipelines, use command line. You can use bat files, PowerShell, and any script language to call your third-party compilers. How can that be done? Well, I can't show you that straight away, but see if I can send a sample to Erika, or maybe send it out, and maybe we can talk about it, or maybe I can show you the link next time, but I don't have time to show it here now. Are we integrating with Docker Kubernetes with Azure DevOps? Absolutely. And you can do that with your Azure pipelines and deploy both doing Docker and Kubernetes. There's no problem. There are build tasks built in for that.
Yeah. I think we have no more questions right now. Right.
And I think there were lots of really nice questions. I'm glad
Yeah.
you had so many questions. It's always
I
fun to ask.
try to.
Yeah.
I try to keep look. Like, oh my god, oh my god. I hope I didn't miss anything. If I missed something, please put it in the chat again. Yeah, I think I got it all. Yeah. So yeah, guys. Thank you so much for all of your questions. If you have any more, just drop them in the chat now. Otherwise, we are going to let Magnus enjoy the rest of his evening. There is something. Let's say, when is the next session? Please confirm here. That's next Thursday. Sorry, what day is it?
Then we're going to talk about GitHub. But there's one question. This seems to be very web-oriented. Is it possible to use the pipeline and test for SQL Server database objects and SSIS packages? Yes. I mean, it's just that the interface is web, but you can deploy or test basically anything. And SQL Server and SSIS packages, yes. It's not the easiest thing to deploy SSIS packages, but it's possible and there are tasks for it. And SQL Server, it's no problem.
Good. Thank you. And then, yeah, there were many thank yous and like that. It's been a great session. So yeah, thank you, Magnus. Thank you so much. I'm looking forward to see you next Thursday, same time here as DevOps Thursdays. And as you mentioned a couple of times, we are going to talk about GitHub intro. There is another question, maybe. Is that? Let's see.
Yeah. I assume using on-prem hosted GitLab can work with Azure DevOps. Yeah. If you have Azure DevOps server and GitLab host on-prem, you can connect with Azure DevOps to GitLab as just any Git provider. So that will work.
Are these videos available for viewing later? Yes, indeed. We have at the Reactor channel on YouTube a playlist, and you just type in championing Azure DevOps, and all of the sessions are going to be available to view on demand as well within 24 hours of live stream. So there's no worries if you can't make it. You can always review.
And thanks again, everyone, for listening in. And thanks, Rika, for having me here.
Yes, thank you so much. Thank you, Magnus. Yeah, have a fantastic evening, and I see you next Thursday. Guys, you've been awesome. Thank you so much as well that you've joined, and I'm looking forward to see you here next Thursday. Have a wonderful evening or day, wherever in the world you are. Thank you.
Thank you very much.
And bye for now.
Bye.